Are joined now for our gas discussion. We're going to talk about the VOG. We have two doctors with us. We have Dr. Evgenia Ilyinskaya and Nadya Moisseeva. And sorry for your name, the butchering of the names again. But we really appreciate you taking the time to talk with us. I would like can you introduce what's your background maybe a little bit for the viewers that aren't familiar? Evgenia, if you've been with the channel long enough, back when we were on a single camera and a single microphone sitting all at a table, right? She was helping us do gas and figure out about the plume back in 2018. And we figured out a whole bunch because of her research and now know more about heavy metal deposits from the plume immediately and its aftermath, all kinds of things about the fallout. So we appreciate her taking the time to rejoin us. And we have Nadya from the VOG Philip, what was the acronym?
The VOG
VMAP,
measurement.
so that's Fog
VMAP.
Measurement and Prediction Program at
There it
University
is.
of Hawaii in Manoa.
Right. And appreciate you guys. So yeah, what are we here to talk about today, Evgenia? Professor
Yeah.
Ilyinskaya.
Yeah, so in summary, we're going to talk about why forecasting models for VOG, like VMAP and others around the world, don't always agree with what we're measuring with our instruments on the ground. So like the Hawaii Department of Health network or the Purple Air network.
Mm. So there's some discrepancies there between the VMAP and the sensors. Is that right? Nadia, I know you're behind that program, yeah?
For sure. Yeah, we forecast VOG using numerical models. So they incorporate weather forecasts and kind of best state of knowledge about what the conditions at the event are. So with this new eruption, obviously this was a very new scenario for all of us. So we're forecasting something that's very different from previous volcanic eruptions that we've been modeling. And obviously there's lots of uncertainties, and I think we're going to talk about all the different reasons why something you're measuring at the surface might not necessarily be matching what the model's output.
All right, yeah, and just to where we come from, we have said this quote many a time, an old quote by George Box, the all models are wrong, some are useful type of thing. And we definitely think of the VOG model as a useful model, especially for the people that are living around the island. It is interesting on this one how the discrepancy between this eruption between this and 2018 seems like the plume is more kind of chaotic, huh?
Yeah, I mean we've got we've got very interesting setup for this eruption. Most of the time we have trade winds in Hawaii, right? So we have very predictable wind pattern. But we got very lucky this time. We ended up with Kona winds and with strong wind shear loft. And our eruption is happening at a very high elevation. So unlike typical eruption like in Kilauea, where we're injecting close to where the atmospheric boundary layer is, where things are near the surface, we understand how things work there. Here we're injecting really high up, and winds can be blowing from right to left in one vertical level, and then you go up another half a kilometer and they're blowing left to right. So if you make a very, very tiny error in predicting how high your plume is, you can just get your forecast to send the plume in a completely opposite direction. So obviously you're going to have an abysmal forecast at that point. So we're playing with very, very complex weather regime, and we're playing with a lot of variables which we don't yet understand, right? Because it's a very new eruption. We don't know how hot the lava is, and we don't know how much it's emitting. So we have to wait for all these pieces to come in before we are able to actually tune down the forecast and create a more accurate and a more useful prediction.
All right. Do you have anything, Phil?
Well, I just wanted to mention to the viewers that we have a written article up by Evgenia that details all the discussion we have here in case you want to refer back to that. But no, go ahead.
All right. So one of the things that we've been seeing, and maybe you can weigh in on this, is that the output of the gas is roughly ballpark to Fissure 8 at its height in 2018, the tons SO2 per day. So is there any what similarities are there besides that to 2018 on the VOG that you guys are seeing, or is it just completely different?
Yeah, you're right. It's the numbers are looking very similar. We should say there aren't many measurements yet available. I think just one that I have seen, maybe another one since then. And actually, the more gas that's coming out, the more difficult it is to measure accurately. So we are, waiting for more numbers, really. But the similarities are, of course, that the eruptions are fairly similar. So it's a fissure eruption. It's not explosive caldera eruption or something like that. So that helps. But as Nadya mentioned, the high altitude, high elevation of the Maunaloa eruption is going to make things very, very different because the atmosphere is very different up there.
Right. All right. And one of the things maybe you can discuss a little more was just about the research 2018, the fallout, right? Because the distance was a key factor in that, wasn't it? Back in that eruption, the distribution of all the heavy metals and things along those lines from the source. So trying to get to like is these metals getting outside of the area of the eruption, which is mostly uninhabited, right? Into the more inhabited areas, in your opinion? I know the data is all prelim and rough at this point, but
so what you're referring to is that we measured heavy metals across different locations around island of Hawaii, and we didn't see very much of them past about 25 miles away from the volcano. But we have to say we didn't get many samples closer, so we don't know exactly when it happens. And we think it happens actually maybe in the nearest few miles that those very reactive compounds get deposited. We hope actually that this new eruption might allow us to collect more samples closer to the source and really figure out what happens to those polluting metals and where do they end up. But we'll see. It's not a straightforward eruption to sample either, I don't think.
Right. Remote areas in a lot of these spots that it's emitting the gas from, especially, right?
Yeah. I mean, we are hopeful, and we've had really great discussions with the USGS about how to make that happen. But we'll always just have to be lucky as well as clever.
Right.
I guess what sorry. Oh, go ahead. I think just coming back to what we were discussing about this discrepancy between the models and the measurements. One thing I want to point out is that models tend to actually perform quite well at predicting when and where the pollution is going to be from the volcano, but it's not very good. So not just VMAP, but models of this type, they're not very good at predicting the concentration in exactly that location. So what we have been recommending when we had eruptions in Iceland, where I also work, is that people use the model and the measurements together. So the model can tell you in advance where you can be expecting it, but the model might be predicting a lot of it and actually find there's very little or nothing. But it kind of helps you know where to look for it. And then you use the real-time observations from the air quality stations to confirm whether the air quality is actually bad at that time. So it's kind of the model tells you whether to bring the umbrella, but that you need to, actually look up at the sky to see if you need to use it.
Oh, that's a good piece of advice there. Because even when you get a forecast, or even when you know where the VOG is, type of thing. I remember this 2018, you know roughly where the VOG is bad. By the time you get there, it might have changed. Or by the time you get a report that the VOG is okay, you get there and it's not okay anymore. So yeah, it's definitely interesting to try and I guess this is as good a time as any to unveil kind of a little project that we're going to put out there, a little bit of a collaboration, but we're trying to gather a little bit of data on how our viewers and the people that live around Hawaii Island are experiencing VOG. If you are out here and you've experienced the VOG or not experienced the VOG, you can fill out this survey that I'm about to drop. And this is the survey that they use in Iceland. It's a very close we've just made a few small little changes to it, and we're trying to collect basically the same set of data that they collect in Iceland to figure out if the sensors and the models, how accurately everything's performing. And with this, eruption, the first time since 1984, we have all these different technologies to help gather data, and it's time to, this gives that real-time stress test to figure out and adjust all the models and everything. And so we're getting to actually fire systems that may not have been fired and tested before in this capacity or configuration. So this is going to help with that. I'm going to drop the link in the chats, so you guys, if you want to fill those out, if you're out here, and that will help. Hopefully, I'm not exactly sure how it's going to be used. We're kind of gathering it now. Everything will be protected, right? We're not going to be sharing addresses and things along those lines. We're just trying to get an accurate picture of what the VOG is like for people that are, around the island. We can collect a bunch of different reports that'll really help for figuring out, then refining the forecasts and refining maybe where we need sensors and things along those lines. So I'm going to be dropping that in the chat. If either you want to comment on that, that'd be amazing.
Yeah, I think it's a really great effort. Thank you, Jane, for setting that up. Just to reiterate, we're not collecting names or emails or addresses or anything like that. So it's all completely anonymous. So we got this idea from Iceland, and we got actually really cool scientific information from this kind of citizen science effort. What we found there is that people were reporting like stinging eyes and other sort of irritation of things on their faces, without SO2 sensors recording very much. And we were really confused why that was. And then we actually, with my colleagues who run a similar model to Nadya's, they ran the model again for longer. And we saw that the plume was coming back like WOG does in Hawaii on the Kona side. It was coming back as like a very particulate rich cloud with very little SO2. And that's why SO2 sensors weren't picking it up, but people were picking it up in their throats and eyes. So actually people's observations made us look closer and run the model in a slightly different way.
All right. Yeah, so we have that out in the chat. I'll be trying to get it out there more over the next coming days as well. We're going to keep it open and just collect what we can collect. Add as much data or information as you can to help describe where you're located and things like that. Mile markers, and like I'm on Saddle Road at mile marker 16, right? Perfect. Like we can work with that. Just general locations so we can figure out where you were and try and put it onto a map, basically. So yeah, that's out there, and we'll be running through that again.
I've got a question. So we can see from the webcams this morning that the flows down in the flow front is down in that lower saddle elevation now. There's a little bit more brush in there, and you can see some smoke from the vegetation burning and drifting. It looks like this morning it was blowing towards the Hilo side. How could people distinguish, or can you incorporate that into your results?
So Philip, are you asking results like, can the model simulate this, or can we distinguish between it, measurements?
Well, I mean more as far as the citizen science reporting that we're pushing here. Do we have a way that people can differentiate and note that, perhaps?
Yeah, really good question. I think basically we rely on people to make as good descriptions as they can. So if they see vegetation burning, there is a free form box to write that in. That would definitely help us. Color of the smoke, because if it's brush fire, it could be more like black or brown, while WOG is obviously like kind of brown or blue net close to source. Smell could be very different. I'm sure people around Hawaii are very familiar with what sulfur smells like, and brush fire would smell different. It's just anything, really anything. I wonder if we could at some point add an option to put photographs in. I don't know, we'll have to ask Dane about that maybe. I don't know if the form allows for it.
I mean, it will allow. I could probably make that happen. The issue is the Icelandic one had an embedded map where you'd like, oh, I'm here, and it would give like a lat longitude. It's like really good, but Google Forms just is not going to support that kind of thing. And yeah, so we're working on borrowed time in a lot of ways when we're trying to do all this stuff during the eruption. So we're just trying to make something up and ship it. So we might add something for photos. We'll see about that a little bit later if we can get that integrated. But yeah, gonna make a stab at and collect what data we can and see what use it is later. So one of the questions I'm seeing in chat is about the sensors and things along those lines that collect the SO2 and the impact that rain would have upon them. Do you know about that? And can you comment, either of you?
Maybe I don't know if the question is whether rain could be mistaken for VOG or by the sensor.
More like it could rain skew the VOG sensor's results. If it's raining, the VOG is lower than it might not be if it was not raining. Type of thing.
Yeah, so generally sensors are not too disturbed by rain because raindrops are much bigger than VOG drops. On the other hand, rain can wash out, a lot of the volcanic stuff out from the air, so make the air cleaner, actually cleaner. I don't know, Nadia, do you have anything to add to that?
Yeah, I think there's a couple of things in play there. As far as kind of the high quality, super accurate, the kind of sensors the Department of Health runs, they are not going to be impacted too much by rain. Actually, everything is measured in a very controlled chamber with controlled pressure for relative humidity. So the measurements track ambient conditions and correct for them. In terms of the impact it would have on concentrations, there are a couple of things that could happen. It could do washout, like in the case of sulfate aerosols that are kind of a byproduct of the emissions from volcanoes. That gets washed out and deposited, but also you could have a reaction where you mix SO2 and water and you get essentially battery acid that you're breathing. So that could become a health hazard while your concentrations of that specific SO2 are lower. So you might be measuring things as things are getting better, but the health impacts might actually be a bit worse, even though the concentrations are not showing up. So it's complicated, and it really depends on the ambient conditions, the ambient concentrations, and at which form the rain is falling, which temperature, how humid it is, how warm it is.
All right. I hope that answers your question from chat. And I think that also answers the question about how they collect gas samples, the Department of Health, at least. If there's any other questions you guys have for them in chat, go ahead and drop that question now. I'm kind of out of questions at this point, unless Philip, you have any more.
I just like to hear something that was written in the article, and I think we could emphasize a little more is this where the VOG prediction is focused, right? And you've written that it's between 0 and 100 meters above ground level. And if we could just talk about that a little bit more, and the challenges you've clearly laid out, how complicated this all is, and how things could be affected by small changes in the variables. But can we talk more about that on the ground versus what's up in the air slightly higher?
You want me to take that, Evgenia? Sure. Yeah, the way the models work is they estimate concentrations by looking at, how much pollutant mass is within a certain modeled layer. So we model these layers as opposed to a specific location. So we have to make certain assumptions about a concentration at a point source, because we're not modeling point sources. We're modeling big grid boxes that have a volume. So when we have a near surface concentration, we actually take an average over this layer between 0 and 100 meters. So, anywhere in that box is where the concentration could be higher technically, but we just don't have the kind of precision. And kind of the more finer scale we go, the smaller those boxes get, and the more specific, more accurate we can get. But at this point, we're at about 100 meters. And another point I want to make is we're only displaying our forecasts for near surface concentrations, but forecasts actually model pollution at all vertical levels. And we just only display whatever is most relevant for people. They're also, if you notice, they displayed a probability of exceedance. So we run the model 27 times and we average the results to give you an idea of how likely something is to happen. So it's sort of like, people are used to precipitation forecasts like POP, right? Probability of precipitation. And if it says it's 30%, you'll be like, well, maybe it will rain. And that's exactly the kind of forecasts we're displaying on our forecast page. It's like, well, how likely is something to happen? So you might see a lot of things kind of moving around, and it's not necessarily that there's a lot of VOG, just that there's probability that there might be VOG. And that reiterates kind of the point that Evgenia was making. It will help you figure out where things might happen. How likely are they to occur?
And do you
I just want to add to that.
Go ahead.
Oh, sorry, Phil. Yeah, I just want to add to that. It's a really good idea when you're looking at any forecast to look in the description. For example, for VMAP, it will say that this is displaying the VOG between 0 and 100 meters above ground level. To understand what is the uncertainty, are you looking at exactly ground level, or could it be anywhere between 0 and 100? And another thing I want to point out to people is that pay attention to what kind of time resolution the model and the measurements are showing. So the model is showing concentration over 1 hour, and it can vary. So again, it's up to the user. It's your responsibility to know what the model is showing. While, for example, purple as they show 10-minute averages. So you can have very short-term peaks in purple as that are not shown by the model, not because the model is wrong, but because the model is showing what is the average concentration over a much longer period. And some models might show average over a whole day, and some measurements might be over a whole day. So you make sure you're not comparing apples and oranges, and it's kind of up to the user to do this.
Yeah, very important to look at those details. Thanks for emphasizing that. When you guys say 100 meters above ground level, that's you're accounting for topography. So you're making a forecast for the summit of Mauna Kea, for example, different than Hilo. That's all incorporated.
Yeah, so it would be following the terrain. So it's 100 meters above ground level, however high that ground may be above sea level.
Oh, perfect. That helps us understand the visuals a little more clearly too. Dane, anything else?
So is that like a difference between being at the summit of Maunaloa and at the observatory or something like that? Is that 100 meters, or is it a bit more?
Something like that. I want to say that summit of Mauna Kea is up at what, 4 kilometers, 4,000 meters, something like that. So yeah, that's just something to people can understand how much care and detail you guys are putting into these models, so that people who are at observatories on Mauna Kea could get equal use of them as people on Hilo. I just wanted to emphasize that.
Yeah, I think another thing to keep in mind is that we go as fine of a resolution as we can, but we're really limited by weather prediction. So we need to know a weather forecast before we can run our dispersion model. And weather models just don't do a good job predicting things at lower than a kilometer resolution, even higher than that in complex terrain. So all of our estimates are they have at least of a kilometer of a horizontal resolution. So it's a fairly large area for which we're making that prediction. So there's definitely uncertainty that's coming from that as well, because some of the valleys in Hawaii are narrower than that, and they can have micro weather happening inside, and they can have little pockets of VOG, which we will just never be able to resolve because our inputs, the weather, are just not provide that kind of a fine detail.
And that's where citizen science might come in useful, actually.
Exactly.
Yeah. Micro observations. Yeah.
All right. I swear I had another question right there, but I just lost it.
Maybe I should. Sorry, go ahead.
Have you been seeing this eruption play with the weather much? We've seen, 2018, it was creating its own little micro climates in there. Is this one doing similar and anchoring like that moisture above it and things along those lines? that's impacting your measurements and your models and all that kind of stuff.
That's a very important point.
Yeah,
go ahead, Evgenia.
I must admit, I just haven't had the time to really go through all those amazing photos and videos. Maybe that's something for, I don't know, people to point out to us as well. So yeah, but I mean, I would be surprised if there wasn't, for example, heavy localized rain or hail. You can sometimes get really heavy hail under volcanic plumes. Yeah, it's always like you always see kind of the same things, but you always see something slightly different in terms of those crazy micro weathers.
I think there have been reports of kind of thunderstorm lightning, this pyroconvection that occurs, but somewhat anecdotal, as you know, as Evgenia, I did not have time to dig through actual data on all of this, but people are definitely noticing very impressive, beautiful, and a little scary weather.
Yeah, if people have time to post it and tag us in it or something, I would certainly be very interested.
Right. I know we got a bunch of photos on White Tracker, but trying to just figure out where the plume is and how anchored it is. The hard thing with this eruption is the sense of scale. Everything is so hard to. Maunaloa is so big, and everything looks exactly the same when you're trying to look at details and things along those lines. I can't even tell where the plume is anchored, type of thing, half the time. Like, is it over here? Is it over there? Is it changing? It's hard, you know. So yeah, it's just a little bit different this time around. But yeah, I did want to talk about the plume creating its own weather, because we had kinds of pretty hectic in 2018, the weather that it would create in Leilani Estates. Anything more you have, Phil?
Maybe one final question, just to remind people, like, what can they do to protect themselves if they are in these situations where they're exposed to fog or particulates?
Yeah, so people who have pre-existing conditions, including asthma or COPD, might be particularly vulnerable. I also would recommend against taking young children where they could be exposed to gas, because they're both closer to the ground and their respiratory systems are just much more vulnerable. So if people have asthma or COPD, it doesn't mean they can't go and see the eruption, but take extra care. Stay upwind, don't go too close to where you visually can see the gas, things like that. For just residents, if they do start to get fog, staying indoors, limiting physical exertion, so anything that raises your rate of breathing, where possible, closing windows, things like that, minimizing time that children spend outside. What else? Acid rain. So when rain starts falling through the plume, like Nadya mentioned, it becomes very, very acidic. So protect things that could be, things outside that you care about. You might want to bring them indoors, because I'm sure people, at least living close to Kilauea, know all about acid rain. But if we start to get acid rain in other parts of Hawaii, that people might not be as familiar with it. Which other thing? So in 2018, we sampled some catchment tanks in Leilani, and we saw slight elevation of some of the heavy metals in the catchment water. So it wasn't crazy off the scale, but if people, we would advise against drinking catchment water or rainwater during eruptions in areas that might be affected by it. Like washing, showering, things like that is fine. But if you're concerned and have kids, maybe don't drink the water. Equally, if you're bringing dogs with you anywhere close to the eruption site, don't let them drink water off the ground.
Yeah, I wouldn't be recommending people drink the catchment water before the eruption. I've seen the inside of those tanks, but definitely.
Yeah, but even treat it. So people treat it with, for example, UV light, which kills bacteria, but it doesn't remove heavy metals.
There you go. So yeah, don't be using the water, even if you're using the UV light. It's not gonna filter that. So is there anything else anybody wants to speak about?
Can we talk about the map?
Anything out there that you've missed?
Just real quick, the masks.
The map.
What kind of masks would be useful?
Excuse me. So after COVID, people are very familiar with types of masks, I'm sure. So masks that filter really small particles are those that are called like N95 or something similar. So they would be good for WOG particles, but they would not filter sulfur gas. The official advice is for general public not to use gas masks because they don't actually work very well unless they're well fitted. In occupational, settings, people get fitted and tested the mask fits properly. So in woggy areas, use N95 or similar mask if you feel it helps you. Closer to the eruption site, if you're going to be exposed to sulfur dioxide gas, just stay out of it. Don't try to protect yourself with a mask. It might not work and might give you false sense of confidence. That's the general advice.
Right. And this eruption, we're not getting thrown into it where people have to, be in the gas type of thing. There's an option not to put yourself in that. Right. That's the big difference to me is 2018. It's like, well, we're taking way too many ppm of SO2 right now, but there's nothing we can do about it. And we're just going to get through it, type of thing. But that's not this one. So
yeah,
definitely.
Absolutely. And I completely, I'm all for people going and enjoying an eruption in a safe manner. Just take precautions, be sensible.
Right.
Don't go where you can see the wind. See the WOG or the gas. What I've seen people, not in Hawaii, in other places, go right up to the lava, and you get carbon monoxide actually coming from underneath the lava, which you can't see. So just be very careful. I recommend not going really close to lava edges for that reason. But yeah, staying upwind, staying higher up on the topography, things like that.
All right. Well, thank you guys for joining us. I believe we have gone through it again. I've dropped the survey a couple times. We'll be throwing that out there and then maybe doing something with it a little later. Evgenia, Nadya, appreciate your time, appreciate your expertise on this, and really taking the time to explain to our viewers the difficulties and the nuance and some of the what about just the VOG here in Hawaii. So I appreciate your time, and anytime you guys want to talk, we'll be here.
Mahalo, doctors.
Thank you.